very good day to sir and my fellow friends. Now we will start the presentation with the topic of smart pothole detection system. First of all, I am Govenjan and I will talk about the background of a smart pothole detection system. A pothole is a large pot-shaped hole in the surface of a road which is caused by traffic and bad weather. The pothole began to form when there are cracks on the roads and vehicles run over the weakened part. Potholes in Malaysia might take days or even weeks to be repaired because authorities have no idea where the potholes are. During the rainy day, road users have poor visibility and potholes are being filled with rainwater. It is dangerous, especially for those who are riding bicycles and motorcycles. Potholes exist on many roads in Malaysia and become a significant problem. Next is the concept of smart pothole detection system. It is a concept of identifying potential road defects using the cloud service technology. A machine learning model is used for video analysis of the road condition. The system will send SMS to authorities and road users when they are within the road location radius. The system will provide the accident rate related to potholes to the authorities. Next part is the history of smart pothole detection system. There are several solutions used for this system. The first one is VRNI, which is Virtual Route Network Inspector. The vehicle-mounted sensor will collect the acceleration data for VRNI to assess the route condition. The work presenter proposed a novel advanced detection method using adaptive support vector machine model. Next solution is Android application with ultrasonic sensor, gyroscope, and image from the Pi camera. The system will map the real-time pothole and alert on Android Google Map. Moreover, users can upload the data or the data will be collected by the dedicated hardware. Third solution is named DeepBus, which is a real-time identification of road surface defect utilizing IoT, Internet of Things. The system will notify the pothole location and warning system for the end users to repair and take appropriate action as well. The fourth is ITS, Intelligent Transportation System, which is used for detect pothole and determine strategy by using 2D image. This system also will provide alert information of pothole to drivers as well. Next slide is problem statement of this project. The first problem is the complaint channel is not user friendly. People have to wait a long time to reach a YB because YB's hotlink is always full of incoming calls. Second problem is exact pothole location is unknown. Repair team unable to find the exact address due to the address is described in voice or text. Third is road users are unaware of the route conditions. There is no pothole alert system to notify them about the condition of the route ahead of them. Last is manual collection and analysis of data. Authorities require a long period of time to collect and manually analyze the route conditions. That's all of my part, thank you. Now I will pass to my next teammate.
The objective of the proposed solution would be to develop a pothole system that equips with IoT camera, and the camera will be monitoring the road conditions and send real-life footage to the cloud service for pothole detections. It is also to notify the authorities and road users about the potential danger on roads. The authorities and road users can get the first-hand notifications as soon as possible with the system. The system will also save, visualize and analyze the road conditions. The locations of the pothole will be saved and analyzed to prevent future potholes issues from happening again. For example, authorities can undergo investigations when a road is found that it has potholes a lot, even though a lot of repair work have been done. Now I'm going to talk about the proposed solution and the architecture diagram. First, road condition will be captured by IoT camera and sent to S3 storage through AWS Lambda. If the image is stored in S3 storage, it will trigger AWS Lambda and send the image for recognition. After recognition and pothole is found, IoT street light will be triggered. An email will be sent to road user and authorities through AWS SNS. The AWS Lambda will also send the image to be stored in DynamoDB. and QuickSight will be used to visualize the data using graph tables for some computational and also analyzation. And the result will be sent to DynamoDB through Amazon Athena and also AWS Lambda. Now I'm going to talk about Amazon S3. Amazon S3 is an object storage service that stores data as objects in buckets. Amazon S3 offers scalability, data availability, security, and performance. S3 can store and retrieve data at any time and from anywhere. In our project, the object stored is image files, which is the road condition images, and also datasets. AWS Lambda is a serverless computer service that runs the code in response to trigger events from other AWS services. Lambda automatically manages the underlying computer resources and backend servers. In our project, Lambda is used to receive trigger from IoT camera, and it will save photos of road conditions to S3 buckets. AWS Lambda will also receive trigger from S3 buckets once the image is stored, and it will trigger recognitions to start to classify the images. And if images is detected, Lambda will trigger SNS and also the smart street light.
AWS Recognition is an image analysis service-enabled application to detect scene and objective within an image. In our system, we just provide some pothole images to train a pothole detection model using AWS Recognition custom label console, and Amazon Recognition API will then identify the existence of pothole within a real-time road condition image. Besides, we also train an accident detection model to detect accident caused by pothole for data analytic purpose. Amazon SNS is a fully managed messaging service that coordinates the delivery of push messages from software application to subscribing endpoints and clients. Amazon SNS can support a wide variety of needs, including event notification. In our case, the SNS topic of interest is created to identify the event of pothole existence and provide publishing messages to subscribers. Meanwhile, the subscribers are road users and the authorities who will be in charge of the route maintenance. Next is the AWS IoT Core. AWS IoT Core is a managed cloud service that lets connected devices easily and securely interact with cloud application and other devices. In our case, the IoT smart camera is remotely connected to the S3 bucket for sending real-time road images and receiving the images. The IoT smart street light is triggered by Lambda function when there is a pothole detected by AWS Recognition.
Now I'm going to demonstrate the system. So this is a project folder in Visual Studio Code, and this is a code that we use to capture image with IoT. So we will capture the image and we will encode the image to base64, and then we will publish the image to S3 bucket in AWS. So now we are going to run it. So we will connect to the IoT core and we will send the image in base64 string format, and we will check. So we have deleted the object, and now we will load the object. So the object is sent April 19 and it is sent just now. So the image is successfully updated in S3 storage. Now I'm going to talk about the Lambda function we use to send image from IoT to S3. This Lambda function will be triggered by AWS IoT. First, it will receive the image and it will decode the image in base64 to a normal image, and the image will be stored in the AWS S3 bucket we specified here. Now we are going into the Lambda function, S3 to recognition, and SNS. The Lambda function will be triggered by S3 bucket storing the image. After triggering, it will get the image from the bucket, and we will create a recognition model, and we will use the ARN of our recognition model, and we will use the recognition model to detect the image, and we will save the result in classified result.
I'm Chai Chang, and now I will show how the Lambda send the email by using the SNS function. So first, the image is classified. If the classified image result is equal to the pothole, and then the SNS function is being called. So when the SNS function is being called, the system will send a message to the user which say that there is a pothole detected in front of you. So we can check for the email and see. So we can see that the pothole is detected, email is sent to the user, and then there is a pothole detected in front of you, sentence is being sent to the user. So the SNS function is successfully being used and sent by the Lambda and SNS function. So the next I will show how the street light is being triggered when the pothole is detected. So I will demonstrate how the smart street light will work. So first I will run the code inside the Visual Studio Code. Okay, so we can see that the Visual Studio Code is connecting to the AWS IoT core. Okay, as we can see, when the image is classified as a pothole, and then it will trigger the street light by sending the IoT data to the endpoint. Okay, so we can see that the message street light is blinking is being received, and the IoT street light is start blinking now. So this is just a simulation to show that the street light is blinking, so we use the word street light is blinking to demonstrate it. Okay, that's all for the smart street light.
Okay, so now I will show how we perform data analysis with the smart pothole detection system. So in order to analyze the occurrence of accident over a period of time, we created a table in the DynamoDB. We named it accident rate to record all the accident information. So whenever Amazon recognition detect an accident due to pothole, we will record down all the details, for example, the image, the location, the date, and the time into this DynamoDB table. Then we will use Amazon Athena to write query to access the table record and to analyze them. The result of the Amazon Athena will then visualize in the Amazon QuickSight. For example, we can see the total accident in a year, in a month, in all location or in a specific location. So with the Amazon QuickSight, the authorities can observe if there is accident repeatedly occur in a particular region, then the authorities can immediately take action by sending people to examine the causes. For example, if it is caused by the geographical feature, then rebuild the whole tar road, or is it caused by the heavy vehicle, then just ban the heavy vehicle from entering the road. So that's all for our presentation. Thank you.
And now I'll talk about the comparison of AWS, Azure, and Google Cloud. Amazon Web Service, also known as AWS, comes with a friendly user interface called AWS Management Console. There are a wide number of applications and services provided in the AWS Management Console. It is simple and easy to operate the powerful AWS. All the services API are well documented and provided in the AWS documentation web pages. It is also able to support large organizations and provide many kinds of service for model training and others. It also has the most in-depth ability to manage resources and able to use worldwide. In terms of security, AWS spent a lot of effort in encrypting all your information, IT infrastructure, and much more to keep your data safe. However, the service may be slow or no response sometimes, and the managing cost is a bit expensive compared to other cloud platforms. Microsoft Azure features over 100 services to help users tackle their problems. Users can iterate quickly and deploy code utilizing an end-to-end cloud development platform due to the Azure agility and built-in development operation. Users are able to debug faster and easier by using the Microsoft Azure Visual Studio Team Service or another open source tool like Chef, Jenkins. It is also able to integrate with Microsoft products and services. But Microsoft Azure is not suitable for large organizations to use because lack of reliability and documentation, and also the price is higher compared to others. Google Cloud Platform GCP works similar to other public cloud providers. It offers virtual machine and hardware which are housed in a regional data center. GCP is mainly a service for building and maintaining a regional application which may be published via the web from the hyperscale data center facility. It more focuses on the machine learning, big data, and image computing services. It also provides load balancing and expansion. However, features are not mature in Google Cloud Platform compared to others, and its operational years is just 7 years.
Okay, so in future we can see that the smart pothole detection system will be a more realistic approach for pothole reporting. So rather than doing it manually by going through a lot of tedious process, for example, submit report, approve requests, and send workers for maintenance, all these things can automatically done by the system. And second, it is more easy for the authorities to determine the exact pothole location. For example, it is hard for the road user to report the exact location while they are driving. So by using the system, the authorizer they can precisely locate the pothole location through the GPS embedded in the smart pothole detection system. And lastly, the pothole data collected by the detection system can provide valuable information for the authorities. For example, if it is discovered that there is pothole always occur in a particular region, then the authorities can examine is this due to the geographical feature or is it because by the heavy vehicle.